How are you guys? Welcome back to my YouTube channel. Today we're still under strength of material N6. We're still under equivalent. What is this? Equivalent bending moments, right? In equivalent. What is it? It's not okay. Sorry, guys. Not it is not equivalent bending moment. We're not yet there. This is a equivalent to what torque. We're still under equivalent torque. We will deal with equivalent bending moment on the next section. Make sure that you have subscribed to my YouTube channel, then you'll see that lesson. Make sure you've subscribed and then you've clicked that notification button so that you'll be notified whenever I post a new video. We have this typical question, guys. As I've promised that I will bring we'll look at this camshaft problem typical question. I've given question 2. Says the camshaft in figure 3.9 is subjected to a torque as well, bending moment due to force F. We don't know that force. Says calculate the maximum force that may be applied in the shear stress in figure. Sorry, why I'm talking about figures that I don't know. In the sorry guys about that. If the shear stress is in the 25 millimeter diameter shaft is limited to 100 megapascal. We have there 11 marks. You see, the set we should determine that force. The aim there is to determine force. Is to determine the force. Oh, by the way, we want the force. Here is the force there. That is the force that we are looking for. So how can we go about this? How can we go about this, guys? All right, okay. This typical question, we need to take it, guys. I believe that we know. Okay, I can start by calculating TE. Remember, you want the force. We want the force. Okay, I can start by calculating TE. Our TE is equals to pi D3 multiplied by the shear stress divided by 16. As we know, I've discussed about this formula. All right, then we substitute our thing pi. What will be the diameter, guys? What will be the diameter? The diameter on this structure, guys, if you're given this, it's a length. We call that will be our length of the shaft. As you can see that it's a length. These, guys, will be the diameter of the shaft. Check, that is the diameter, obvious. Remember, here is the shaft, is entering there on the camshaft. That is our shaft, guys, there. That this will be a diameter. So make no mistake about it. Not be confused. Remember, it's entering there. That is just is entering here. You see, that is our shaft. If you continue and write that, that is a shaft. So our diameter there of the shaft is 25. This is our diameter. All right, as you can see, that diameter is 25. 25 is the same as 0.025 meter. The length is the same as 0.3. Right, this will be the radius. This distance, guys, of the cam, it's our radius. That is the radius, guys, is r. So our radius there will be 0.2 meter. All right, so the diameter, as you see there, is 0.025 raised to the power of 3 multiplied by the shear stress. Shear stress given there is limited to be what? 100. We have there 100 megapascal. All right, 100 megapascal times 10 to the power of 6. Times 10 to the power of 6. So this divided by 16, isn't it? So typical punch this on the calculator. Then if you punch this, you'll get that TE is simply equals to what? 306.796. Obvious is measured in Newton meter. So we are done with this. So then what next? We are done with DE. So my question, we have DE. We know that equivalent torque, it's equals to the square root. I've shown you this formula, maximum torque squared plus maximum bending moment squared. All right, but we don't have the torque. We don't have the maximum torque. Again, we don't have the maximum bending moment. So how do we go about this? So how can I find that? Guys, okay, we want the torque now, the maximum torque. Yeah, the maximum torque of the shaft, that will be given by force multiplied by R. We have, I'm sure, the R there. Remember, this is a camshaft. We have the camshaft, it's a shaft with the camshaft. Our R is this one, guys. From then till I've shown you, we've shown by this area there, as you can see, it's our 200 millimeter there, which is 0.2. That is our radius. So a force will be multiplied by 0.2, which is our radius. This is the same as 0.2 F force, right? This is our torque in terms of what? Of F. We have this torque now. All right, we have the torque then, and this, guys, is the maximum torque. All right, now how can we find the maximum now bending moment? All right, you know, I've talked this, guys, as you can see, this, guys, is overhaul. It's like this, guys, you can see this, you can tell this is the cantilever, it's fixed there. It is in the form of cantilever. Bending moment there, if you're dealing with cantilever, will be the weight that you see, that, remember, that is applied there at the end, that we are given, because there at the end then multiplied by the, will be multiplied by the length of the shaft. By here it's a length there, which is 300. So we know maximum bending moment will simply equals to the weight. But now the weight here is the force, guys. You have seen is not W. Weight and the force, it's one and the same thing. Just is the force. We can say force multiplied by the length. Yeah, this is the one and the same thing as W multiplied by the length. Remember, force and weight is calculated by the same formula, mg. So the force, we don't know the length there. What is our length? You've seen there will be 0.3 due to what? We've seen this is 300 millimeter, then divide by 1000 is 0.3. So by the way, when now we multiply these twos, we'll have 0.3 F. That is our maximum bending moment. So we have maximum bending moment. Now we can use our typical question. We can use our typical formula. We have here TE. We have said that it's equal to the square root of maximum torque squared plus the maximum bending moment squared. We have these, guys, we did calculate that from our previously. You see, TE is this that we got there, 306.796. 306.976. We have said this is 306. Is 306.796. We have now equal to the square root. Our torque there will be in terms of the F. Actual value, want to calculate the F force, it's what is 0.2 F. All right, we have 0.2, oh my bad, 0.2 f, then we square this plus the maximum bending moment, that will be 0.3 f. We square this just like that. So nevertheless, you know the math. You square both sides. How can we get f? The force, you square both sides. There will have 0.6 comma 79 comma 7 comma 796 squared like that will be equal, the square root and the square will cancel. Will typical will left with 0.2 f squared plus 0.3 f squared. So you know what you're supposed to do. Or guys, you know what you're supposed to do. So we're adding, we know the maths, be familiarize yourself with the mathematical skill. Just familiarize yourself with the mathematical skill. This you still have 36,796. You see, if it's your mathematical skills is not good here, we are doomed. So this is same as you square that. You square that is the same as 0.2 squared f squared. You know maths, plus 0.3 squared f squared. You know most laws of exponents. Guys, we have f squared, we have f squared. These guys, these are like terms. You add these guys, it's the same as you are adding now. Or be wise. If you are wise, you can take out f as a common factor, f squared. If you are wise, you will be left with 0.2 squared plus 0.3 squared. Then you simply now, if you are wise again, can do this. Now you divide by that, 0.2 squared plus 0.3 squared. This and this will cancel. Come again, you divide by 0.2 squared plus 0.3 squared. Then this, what I'm doing there, sorry. Okay, then we left with this, we left with f squared into this now. Squared, reason it divide by 0.2 squared plus 0.3 squared. So simply take the square root both sides to cancel that. If we are taking the square root, I don't know about you, but my math says it's supposed to cancel. I will have f. That is the math. My math says it's supposed to have f. Then I punch this on my calculator. Alright, I have to punch this, guys. By the way, I supposed to do this square root of 3 square root of 306 306,796 squared all over 0,0 over 0,2 squared plus 0,3 squared. Right, what do I have here? 850. Right. Yes, 850.99. All right, this is nice. 850.9.89. Okay, comma 8. This is 899. Obvious is measured in what? In Newton. It's a force. So this is how you calculate this typical question. This is what the force that they needed, that got all of that 11 marks. So simple like that. So this is how you go about finding your force. These are necessary steps that you're supposed to take, guys. So let me ask you guys, let's say now you're given, okay, let's say now you're given a density. I want to know, maybe I'm curious, you might find that someone does not know this. Let's say you're given a density, let's say it's 800. I'm just picking any number of the density there, and you're given the diameter of the shaft, which I can say is 25. Let me say 25 millimeter. And then this, obviously, this is the density of the shaft. This is the diameter of the shaft. Then the question says, I'm just curious to know. Let's say, I think this is supposed to know. Let's say, determine the weight. The question says determine the weight of the shaft. Per meter length. It must be per meter. I'm curious to know. Let's say I'm giving you the length of the shaft is 2 meters. I want to check something here, guys. So they say what they want the weight. Here is the question. I can say A. You are just given, I give you this data here on the top. They say now determine the weight of the shaft per meter. How can you calculate this? All right, how can you go about this, guys? If may I ask, how can you go about this? So you must know now, one day they said per. Even if you are given a length is equal to 2, do not use that 2. You cannot use that 2 because it's per meter. That means 1 meter, guys. You'll take it as 1. Take a note. Do not use that that 2. You'll be wrong. And then again, we must be curious. Remember what the weight. All right, let me just do like this, guys. You must know that mass is equal to what? Density divided by what? Let me not go to mass first. Let me just say, I know you're used to this. Density is equal to mass divided by volume. All right. Now, let's say we want the mass. If you want the mass, you'll just multiply that side. The mass will be what? The mass now will be density multiplied by what? By volume. All right. This is what we have. Now, if you have the mass, guys, you have the mass like this. Already you have the mass. Remember now, guys, the weight is equal to mass multiplied by G. Already our mass is equal to this. If I take that, I substitute that there, I'll have weight is equal to density multiplied by volume multiplied by that gravity. Now this will become weight now, this whereby it's in newtons, because our mass, guys, here it's our mass. We'll substitute it like there. This will be our weight now. I'm talking about the weight of the shaft. Guys, what is volume now? I'm talking about volume it's a area multiplied by the length, area. All right. So area, this is it's given a diameter. If you're given a diameter, obviously it's a solid shaft. This is a shaft. It's like that. I just give you one diameter. That means it's a solid shaft. You know the area is pi over 4 multiplied by d squared multiplied by length. But they said per meter, your one, you'll take it as 1 meter, guys. So we are okay. We have our density multiplied by volume, but the volume is this, guys, is pi over 4 multiplied by d squared multiplied by the length. Also we have that gravity there multiplied by the gravity. All right, guys, are we together here? Are we together? Are we together? Right? Are we together? I'm curious to know. Just curious to know. Are we together? So we have now, this is the weight. All right. Then we'll substitute our density. Whereby the density I've said is 700, 800. All right. 700, 800. Multiply by pi over 4. Now the diameter I said is 25, whereby now 25 is same as 0.025. Remember, it was in meter. Then you square, you multiply by the length. Do not use 2. I said per meter. Then you use 1. Use that 1 meter per. We multiply this by 1, guys. Multiply this again by gravity, which is 9,81. Then your weight, what is that? 7,000. Sorry about that. 7,800. By the way, multiplied by pi over 4 into 0,025 squared. Multiply by 1, multiply by 9,81. All right, this will be, we have here 37, 56 1. Remember, weight is measured in what? It's in newtons. This is how you go about. Just show you this. They might throw this question. So I've shown you guys. I don't want you to get wrong here. You can calculate these, guys. You see, maybe they can say 2 marks or 3 marks. So this is how you can get these, guys, isn't it? Do not make mistake there. You can get this so simple. So yeah, our lesson will end here. By the way, as you know, as always, guys, those who do not, as always, thank you for watching. And by the way, those who have not subscribed, please, guys, please, may you kindly subscribe, guys. Let us grow together. May you kindly subscribe to my YouTube channel and click the notification button so that you'll be notified whenever I post a new video. And then feel free to share this to your fellow classmates, and then feel free to comment and like. All right, when you subscribe, guys, you're giving me energy to post some more videos, guys. I'll keep posting. Just subscribe there. I'll bring this nice content to you, guys. Let's grow. Let us just become the part of the family. Let us grow together. As you are passing, let me